After watching the process of making giant gears in Pakistan, I finally understand why is Pakistan's industry lagging behind. But he is called the mechanic of the world. Those industrial powerhouses need millions of dollars. Special giant gear that can only be made. Pakistan doesn't need the blessing of technology. Only using primitive methods accomplished such a feat. And it only costs 100,000 rupees. Slammed the high crystal industry in Europe and the United States. Let's take a look next. How did the Pakistanis produce giant gear bar? The first step is to build a furnace used to dissolve molten steel. The inside and surface of the furnace. It needs to be covered with a layer of soil to prevent the smelting iron and steel stone from burning and passing through the furnace. Use billions of mountains as ignition. Light the fire. Prepare to smelt molten steel. The next step is to come to the raw material stacking point. Selecting the raw materials for casting giant gears. These recycled metals. It is the Pakistani who cast special workpieces. The casting materials used, although they don't have Gundam on alloy steel products, but the Pakistanis own a unique steel-making technology. We can also recycle these metals, refined into alloy steel that meets international standards. Workers use carts to recycle metals of different materials. Line up. Aluminum frame made of iron sheet, steel pipe suction block, and other raw materials. When the furnace fire reaches its peak, these can be classified as good metal raw materials. Pour into the furnace in sequence for smelting. The process of smelting just water seems dangerous. It's not safe at all. Just finished. Pakistani workers who like to work in slippers. I was scolded by the sparks when smelting molten steel. Workers on the other side. The soil method taught by the Eastern Slope is being used to make casting models of giant gears. First, dig a diameter out of the mud. 1.5 meters of casting pit and lay a layer of ponton soil at the bottom of the pit. Peng Run soil has strong cohesion, high plasticity, easy demolding, and other advantages. It is the material of choice for making large bow and arrow molds. After the bottom layer Peng Run soil is laid, the worker brought a sun-shaped gear wood plate mold. Place it in the center of the casting pit. Then a square wooden box is installed in the middle of the gear mold. After the wooden box is installed, then put the top layer. The gear wooden board mold is covered on the wooden box. This step is just completed. Installation of gear column grinding positioning device. Next step. Workers begin to make casting models of teeth. First in the tooth bud print mother. Lay a layer and add black casting diagram of mold release agent. Then fill the black casting drawing with yellow shed soil and use a tool to cast the drawing to cause tighten. After soldering, buckle the print mother upside down to the ground. After removing the seal, a cast model of a tooth is made. Wait for the model to harden and then you decorate it with iron in order to make the post-casting finished product more regular and beautiful. The tooth model has been made. To elderly workers, place the tooth model on the positioning device. Ruler groove on positioning device. It just matches the dental model. This will ensure the accurate placement of the tooth model. Make a complete giant gear mold. A total of 16 tooth models are required. And this one weighs more than 30 kgs. To install the worker's lumbar spine. That was a big test. After all the tooth pressure models are installed in place, Workers backfill the casting pit with soil with shovels. These fill-ins can provide support, the function of fixed gear grinding neck. After filling the casting pit, use tools to fill the soil around the casting pit. Give him a dash. This ensures the stability of the casting model. After aerial filling, a layer of shed moisturizing soil is laid on top of the fill and shape it into a square platform. Fill the ventilation holes on the platform, pouring hole positioning hole and other holes. And then he made a square mold. Place it on top of the gear column mold. The function of this square mold. It is used to cast gear lifting points. It is convenient to pull out the casting pit when the gear is formed later. Then plug in the positioning iron and glue bamboo board. Prevent bentonite from plugging these important holes. The next step is to tighten the gear. Place 5 bricks on each side. After the bricks are laid out, pour the shed soil into the square mold. After the shed moisturizing soil fills the square mold, tamping with tools. After bran, and then you surround the bricks with pounder soil, shaped to kidney-shaped dirt pits. Then take out the bricks in the pit, and carefully modify the shape of the pit with a scraper, and these to kidney-shaped soil pits. It is the casting model of the gear lifting point. The hanging point model has been shaped. Workers used cranes to move the upper model away from the cast. After the pit is built, remove the wooden plate mold inside the gear model. The gear model in this case still has some flaws. Workers will use Pangrunpool. Repair the curved area. It also makes the later gear products more complete. After fixing the curve, the worker adjusted a cylindrical mold, and we put it in the center of the gear model. Cylinder mold is a shaft hole for shaping giant gears. And finally, cover the fishing point casting model on top of the gear model. So a complete giant gear column mill. And that's done. To prevent the molten steel from washing away the upper model. Before pouring the gears, it requires 6 tons of mulberry iron to suppress it. The preparations are complete. Start pouring. Come to the melting point. Workers are using tools to skim impurities from molten steel. Then align the ladle with the discharge port. The Tenton furnace was slowly lifted. Transfer the fiery red tank water to the tank water bag. The worker in slippers stands by the stove. Observe the filling situation. He's not afraid of the mop premise. Soon the 3-ton ladle filled with molten steel. Transfer it to the gear focus point. After the transfer is in place, the worker climbed on top of the silo iron. Use a tool to remove the foam from a piece of molten steel. To ensure the purity of molten steel, the worker then turns the ladle chopper. Fiery red molten steel flying down. A steady stream of attention was poured into the gears. See here. Not only admire the casting skills of Pakistani workers, I admire them even more in such an environment. Dare to work in slippers, in a mortal body. Tough guy migrates molten steel. It's really a little sparrow that makes the cow happy. Really awesome. Half an hour later, 2/3 of the 3 tons of steel water poured in. Can't imagine. How big will this finished gear be? After pouring is completed, it needs to be naturally cooled for 2 days and 2 nights. After 2 days, the miscellaneous mill will be unpacked. Tie the spreader chain to the gear ceiling. Then the crane welding iron pulls the onion. One force pulled the giant gear out of the pillar soil. Freshly baked geared swords. There's a lot of stuff stuck to it. Workers are needed to clean it up with steel and lead. After cleaning up the excavation, Transfer the gear to a flat surface and cut off the hoisting point on the gear with a cutter. The lifting point is removed. The worker drove a tricycle. Prepare to move this giant gear. Transfer to machine shop. A giant gear weighing 1.5 tons. Loaded on the freighter. The tricycle is obviously undercut. After loading for public inspection, the rickshaw hits the accelerator. Came to the machining workshop. Young worker. It's a crane that lifts giant gears. Mechanic in Pakistan. It starts with dolls. 15 years of work experience at the age of 20. No wonder their hands-on ability is so powerful. After hoisting the gear to the window, turner starts lathe. First machine the plane of the giant gear. The turning tool that cuts iron like mud rotates with the gears. The plane of the gear and the shaft hole are machined. The next step is to move the giant gears, hanged onto a historic lathe. Next, the teeth and alveolar, performing and processing. The processing difficulty of tooth and tooth cogging. Direct bid regional level. Not only does it require a superb lathe foundation, but also be patient and focused. Processing teeth and teeth etching begins. The lathe has to stand by the lathe. Every time I cut, it needs to be adjusted manually by the lathe and process a tooth groove. It usually takes 5 hours. 16 teeth. That's 80 hours. As you can imagine, how difficult is the processing of giant gears? After a week, the machining of the giant gear is finally complete. Such a giant gear can be sold locally for 200,000 more. Do you think he is worth the price?